Hello everybody, in this video we're going to look at decidable and undecidable problems as well as heuristics with a walkthrough of code.org's 10.4 and some practice questions as well. Alright, let's get going. If you're looking just for the review questions, please skip ahead now. So I'll start out with a slide from code.org and ask the question, can I visit all of my friends' houses? And the answer is yes. I could go right, up, left, and back down. So this is an example of a decision problem. Decision problems are yes/no problems. And this is a vocab term on the AP CSP exam. So in this case, the question is, can I visit every friend's house? And the answer is yes. Yes, I can. Again, this yes or no question is a decision problem. So now you might want to ask the question, which of these paths is the best path? So I have the path I tried before and also more. So I could go diagonally down, or I could go up, diagonally down. And if I had the distances between all of these houses, I can make the calculation and I can answer which is the best or shortest path. So these kind of problems are called optimization problems. And again, this is another AP CSP vocab word. And basically we're asking which is the best. In this case, we're asking what is the shortest path to visit every friend's house? And our answer in this case is 4 units. Again, vocab word, optimization problem. So now we're going to change it up a little bit. We're still going to ask an optimization problem, but we're going to ask what is the shortest path now that we've added a whole bunch of houses. So before, with only 4 houses, it's kind of easy to brute force all the combinations, but now we have many more combinations, and it's much harder to brute force that answer. So this problem has a name. It's called the traveling salesperson problem, and this problem scales as n factorial, where n is the number of items you have to go through. If you look at this chart here on the right, you'll see quickly that there's too many things I have to check. If I'm checking 10 houses, then it's 3.5 million checks I have to do. If you remember the previous lab, when something scales as n to the factorial, we say that it's unreasonable. But we still have to solve these kind of problems. So what do? So when this happens, we use something called heuristics. And heuristics are just approximations or rules of thumb that allow us to not have to use the full algorithm, which would take an unreasonable amount of time to finish. Specific heuristics are not going to be on the AP CSP exam for you. You just have to know that they exist. So whenever we see that the exact solution takes too long, we're looking for a solution that's good enough. The alarm bell should be going off for you. You see a question like that, you know the answer almost always has to do with heuristics. We're going to go over one specific example of heuristic. But again, if you see an unreasonable problem and you have to try to solve it and it's on the exam, heuristics to the rescue. The last thing I'm going to go over in this introduction is the word undecidable problems, which is a vocab word on the AP CSP exam. So you might remember from before, we had a decision problem, which means the answer is going to be either yes or no. And the question we asked was, can I visit every friend's home? Well, there are certain times that the problem is going to be undecidable, and that is when there is no algorithm that can give me a yes or no answer every time. Maybe it works sometimes, maybe it doesn't, but when this happens, the problem we say is undecidable. Again, you'll probably see one question or so on the AP CSP exam about this, and we'll give you some practice questions so you can recognize when that happens. Here are the code.org activities, and in these activities, code.org is demonstrating to us an unreasonable algorithm and then having us use a heuristic or rule of thumb to find a solution instead. So in this app, they want us to click run. They want us to click on the nodes to create a path. We want to visit all the nodes and then return back home. So I'll do that now. I'll click run. And maybe I'll go here and here and here and here and here and here. I'm just kind of clicking anything right now. So my score is 1429. So let's try again. And now my score is 2088, which is a lot worse. There is an algorithm which will give me the exact answer, and that is for me to try every single combination of connecting the dots and then going back home. But the problem with this algorithm is that it scales as n factorial. And as we learned before, things that scale as n factorial are unreasonable. If you grow the system just a little bit, they start to take way too long. So what we're going to do instead is use a heuristic. And here's my heuristic, that I'm going to just go to the nearest one. So if I take a look, nearest one is 113. Take a look around here. Nearest one's 83. And I get 1668. Now, is this the best solution? No, it's not. I got 1,428 before. but it's a lot faster. With this heuristic, there's only one combination to try, whereas with a full algorithm, I'm trying 479 million combinations. So this heuristic is 479 million times faster. So the bottom line for the AP exam is if you have an unreasonable problem, use a heuristic. You're going to get an approximate solution that's good enough, and it turns an unsolvable problem into a solvable problem. Second code.org activity is pretty much the same. I can generate different levels here, so the dots will look a little bit different. But if you try it out, what you're going to find is more or less the same thing. The heuristic might not give you the best answer, but it's going to give you the answer a lot faster. I'll reset that, and if I just try to go randomly, 1369, that's a little bit worse. And again, I'm going randomly. I tried just 2 more there, and my heuristic gives me the best answer. So that's what code.org is trying to do. They're trying to illustrate that the heuristic is basically just a rule of thumb. Here's a specific example of a heuristic, and in this case, it's good enough. Undecidable problems are not covered by code.org. They ask you to watch this video. It is a great video, but there's a chance you won't understand it, and that's okay. Just look at the practice questions to see how you're going to answer these questions when they come up on the AP exam. All right, here's code.org's question. The first question is, in which of the following situations is it most appropriate to use a heuristic? Remember, we're going to use a heuristic when we reach the limits of our computing power, and the limit we're reaching is when a problem is unreasonable. So, A, the only algorithms that provide exact solutions run in linear time. No, this is not true. We've seen lots of examples of reasonable problems that run in times other than linear. So again, A is not true. B, the problem has been identified as undecidable. No, we use a heuristic when it's identified as unreasonable, not undecidable. Undecidable is different. C, the only algorithms that provide exact solutions run in unreasonable time, but exact solutions are not necessary. So this is what we just did, and C is your answer. D, 2 different algorithms have been identified that solve the problem in reasonable time. No, if we could solve the problem in reasonable time with an algorithm, we don't need a heuristic. So that's not the answer. Finally, this last question here is asking about the difference between undecidable and unreasonable problems. So unreasonable problems are problems that take too long to finish. They scale really poorly, so even though there's in theory a way to solve it, you can't really solve it in practice. And so what we do is we use heuristics or approximations or rules of thumb to try to solve these problems. Undecidable problems, these are problems where we are looking for yes or no answers, and there is no algorithm that will always work to give us this yes or no answer. When you're taking the AP CSP exam, you should in your mind pair unreasonable with heuristics, and when you see the word undecidable, you should pair that in your mind with there will not always be a solution. Here are some practice questions. Number 1, here are some problems. Which would be yes to use a heuristic? 1, calculate the average GPA of a student. No, we're not going to use a heuristic here. Here it's very straightforward to calculate the GPA, so this is not it. 2, calculate the maximum lossless compression of a 1,000-page book. So this is a classic problem where we're using heuristics. You may have done lossless compression as part of a code.org activity. This is not a reasonable problem, especially the longer and longer we get. So here's where we use a heuristic. And 3, shortest drive from Anchorage, Alaska to Mexico City, Mexico. This is also a classic problem using heuristics. Anytime we're looking for GPS stuff, traveling salespeople, these are all heuristic type problems. Again, it's a problem that scales as n factorial. It's not going to finish in a reasonable time. So because of that, we use heuristics. So the answer here is C. All right, question 2, another similar problem. Which would be best to use a heuristic? 1, computer chess program where maximum time between moves is 5 seconds. So here, because of this time pressure, I need a shortcut. And when I need a shortcut or a rule of thumb, think heuristics. So this is true. 2, encrypting internet traffic between 2 computers. No, this is not. It's not an unreasonable algorithm. It's a straightforward algorithm to encrypt internet traffic. So this is not the answer. 3, a program that finds the maximum number in a list of numbers. Many of you probably programmed this already as part of your coursework. And if you did, you know that this is a pretty straightforward and fast algorithm. You do not need a heuristic. So the answer here is A, 1 only. 3, I have an algorithm that works when there are 3 items, but is extremely slow to finish when there are 6 items. One of the following is most true. So in the previous problems, we're sort of making it obvious right away whether something is unreasonable or not. In this problem, we need you to recognize that it's unreasonable from the symptom, which is that it scales really badly. So once you recognize that it's an unreasonable problem, you know you're looking for a heuristic, which of these options, the only one is D. The other options have to do with undecidable problems, optimization problems, and then some mumbo jumbo that's just meant to confuse you. So the answer here is D. Question 4. These next 4 questions have to do with undecidable problems. And the way to answer all of these questions is to recognize there's no algorithm that can give a yes or no answer every time or ever. You don't actually have to really, truly in your heart understand what undecidable means. You just have to recognize the keywords. So the question, a random computer scientist declares a problem undecidable. Right away, based on keywords and key phrases, you can see that it's D. For at least one instance of a problem, there is no algorithm which can give a yes or no answer. It's not going to be A, which has to do with unreasonableness. It's not going to be B, which also has to do with unreasonableness. C is just some mumbo jumbo to confuse you. So again, the answer is D. 5. One of the statements is most true, which A, given a fast enough computer and enough time, all problems can be solved with an algorithm. No, that's not true. If it's unreasonable, it's not going to be solvable in the time that you have available. It might be solvable at small inputs, but with big inputs, it's not going to be solvable. B, all problems can be solved with an algorithm. Right away, we know that's not true because of the concept of undecidable problems. C, a decidable problem is concerned with finding the best solution to a problem. No, decidable problems are about yes and no. Finding the best solution is an optimization problem. D, some problems cannot be solved with an algorithm, even with infinitely powerful computers and infinite time. So we see the phrase one more time, some problems cannot be solved. Right away in your head, you think undecidable problems. And that's what we're looking for here. This is true. The answer is D. Question 6. Jojo wonders if a problem is undecidable. One of these can be used to determine the answer. So once again, with undecidable problems, you don't really need to know what's going on. You just need to look for the correct phrase. No algorithm can give a correct yes or no answer every time. So the answer we know right away is going to be D, but let's look at the others. A. Use citizen science to gather a lot of data to prove the problem is undecidable. So citizen science is a topic on the AP CSP exam, but it has nothing to do with this problem. So it's not that. B. Show the problem can't be solvable under normal conditions, but can be solved if the internet bandwidth is increased to theoretical limitations. That's just a bunch of jargon, mumbo jumbo. You should ignore that. AP all the time will try to distract you with this kind of stuff. You gotta ignore. C. Show the problem is unsolvable because of problems attributable to the digital divide. So the digital divide, again, is a topic on the AP CSP exam, but it has nothing to do with undecidable problems. So we're going to ignore that one again. Alright, so that's pretty much it. Hope that was useful to you. And if it was, please give this video a like and subscribe to my channel. I'll see you next time.